Hi, this is Jim Montague, Executive Editor of Control Magazine and ControlGlobal.com, and this is the fourth in our new Control Amplified podcast series. In these recordings, we're talking with experts about important topics in the process control and automation field and trying to go beyond our print and online coverage to explore some of the underlying issues affecting users, system integrators, suppliers, and other people and organizations in these industries. For our fourth outing, I thought it might be useful to talk to Will Aha, Vice President of Customer Operations at Panacea Technologies in Montgomeryville, Pennsylvania, and also a member of the Control System Integrators Association. Will has been one of Control Magazine's most interviewed system integrators in the past few years and has given us a lot of expert insight into in-the-trenches system integration projects, issues, and solutions. One of his areas of expertise is historians and data analytics, which we'll be covering in two upcoming stories. And as is so often the case with my sources, he's going to clear those topics up for me so I can actually produce stories about them. Oh, and one more thing. Since we've got two stories, we may be able to do two podcasts on these topics, so this may just be part one. Okay, Will, sorry for the lengthy preamble, but thanks for joining us today.
Yeah, I'm excited to be on the podcast.
All right, let's get started then. I guess first up, if historians have evolved to the point that any device with a microprocessor and software can be set to collect and store long-term data, then what the heck characterizes a historian these days?
That's interesting because I think that at their core, historians are still what they were when they were kind of first developed, which is a way to store data, a way to historize data. I think that's really what still characterizes a historian and still holds true. And they've gone through a lot of changes, but I think the big thing that we're seeing is that there's more of the way that a client would classify what their historian is rather than what the software is itself. And I think that they used to classify it very much as throw the data in there and it doesn't really matter, just collect everything and put it somewhere and we'll run reports on it later. And I think that they're starting to classify a historian in the same way that you would classify a utility. So data is a utility. It's no different than chilled water or steam or Wi-Fi. It's now a utility. And I think that's been the big change is there's a lot of value in it. And if you kind of view it as this stream of value and stream of importance, historians are being treated much differently because of that.
So, given how much historians have changed, and in what kinds of new ways are they being applied where they maybe couldn't be used before?
So I think one of the big ones is obviously there's more data being collected. The storage used to be a very expensive issue for historians. Memory wasn't cheap, so to speak. So you weren't likely to collect absolutely everything as quickly as possible because it just didn't make sense from a cost perspective. And now one of the big changes has been that you can really collect everything as quickly as you want. And it kind of goes along with that, IoT, and by year, whatever it is, will be this much data, which brings its own issues with collecting all the data. But that's a big one, is that they changed to be able to collect a bunch of data all at once and be able to store it long term. But some of the really interesting ways that historians are changing is, one, they're changing from what we see the way that processes are designed and physically coded. And what I mean by that is that there's a lot of efforts that's going into creating code and creating, specifically in batch applications, batch models that have triggers in them that can show you when certain processes start and stop. Because as anyone listening to this podcast has probably been through, when you run a batch or you're doing some sort of investigation on data, it can be very difficult to go, okay, when did we run the batch for that product? Well, it started on this day. Okay, so go pull all the data from this day at, let's just take a guess and say 6 a.m. to 4 days later when it ended at 4 p.m. And then we're going to have to go through and clean and then actually figure out, when the data is that we're looking for. So being able to characterize that data has been something that is new, that you're able to start setting up very intelligent reports and be able to pull reports in a way that's a lot easier. So when you're doing investigations or you want to get some data out, it's a lot simpler than it used to be. The other one is the things like PAT modeling, which PAT stands for Process Analytical Technology. It's the same kind of concept as multivariate analysis. And that's something that historical data and data historians are enabling in a way that we haven't seen used widely as it is now. So being able to take data that exists and take real-time data that's being put into a historian and actually crunch it into a high-level calculation set and be able to make changes to your model or make changes to your control as data is being collected is huge, and that's something that we're seeing. And really, the final one that I would say, and the big one that we get excited about, is that historians are being used more for using data, so putting data to use and making actions upon data and making decisions upon data and changes upon data rather than just simply grabbing it.
So then is that part of the overall mindset of thinking of data as a, utility stream like chilled water? How do those come together?
Yeah, of course, because now data becomes useful. Now it's not just something that you store on some disk that gets backed up and gets put in some storage facility so that you can have it if a regulatory agency comes knocking or you want to look at it later. Now it's utility. Now it provides value. Now it's something that everyone in your plant wants access to and wants to be able to use it in some way and make decisions upon it in some way. And that's been the big changes. It's just as important as electricity or just as important as chilled water. It really is utility because it's something that runs through your facility and it's something that everybody can use and everyone can use in a productive way.
So then, once all this data is gathered and stored and people begin to use it, and I guess since the only thing that changes, faster than hardware is software, how are data analytics tools and techniques changing lately? They must be going, through the same kinds of shifts. I guess everything is in the cloud maybe, but, what are they doing there?
Yeah, and we are seeing a lot of shifts in overall reporting tools and software, some for the better, some is just noise in our opinion. And what I mean by that is that the big thing that you're hearing right now is artificial intelligence and machine learning and all of that. And actually, I saw a post on LinkedIn the other day, and it really had me laughing, but it was a video about some of the issues that companies go through when they deploy data type systems or software. And one of them was they were kind of making a joke about how nowadays it's like every company has something they call machine learning that chugs data and produces a nice graph, and everyone's wowed by it. And I think that we can start with the negative side of things because I'd like to end on the positive with this question. But from the negative side, we see a lot of changes happening to software that you saw with IoT, which is everybody and their sister company is creating a artificial intelligence / machine learning reporting platform. And they all look very similar, and they all do a lot of the same things. And you'll hear the same type of marketing terms around driving KPIs and things like that. And there's some caution there in the same way that we had talked several years ago about the caution of making everything an IoT device, which is there's at its core artificial intelligence and machine learning is, for what we're using it for, is still just somebody that's come up with an algorithm that they're applying to a data set. And unless you're contextualizing that data or you're feeding correct data into it, then it doesn't make much sense. I mean, pretty much anybody can come up with a piece of code that chugs data and puts a nice little screen out and call it machine learning, but that's not really what it is at its core. So that's something that we see kind of on the trend side that's been interesting is a lot of companies go into clients and sell them on the idea of we're going to put in an AI platform and we're going to put in this machine learning platform, and then they buy it and then realize that it's not as simple as just hooking your data source up to it and boom, you've got all of this great data. There's a lot of cleaning that goes into it and a lot of contextualization. And if you have disjointed historians or you have multiple data sources and multiple places that you're aggregating data into, it can be a little bit more difficult. So that's something that we see. And then I'm sure that, I think we talked about this a couple of months ago where it was kind of the same thing as everybody said, oh, great, IoT devices, put everything on the network. And then once it was there, then it was like, okay, well, now what do we do with all this stuff? And it's the same kind of thing.
Kind of like the, curve of expectations and the trough of waking up to reality, the common technology. I forget the exact name of the curve, but it's like that, where everybody gets excited, says they're doing it, and then reality sets in and the honeymoon is over, I guess, right? Yeah,
and that's really what it is that it's, hey, here's this great analytics platform, and you put it in and it tells you, hey, you had a downtime event at this time because this data dropped down, which is great, but you could have known that without having that machine learning platform. And that's not to say that there aren't some great platforms out there. It's just that that's something that we'll see is the rise of every company has a And you can always kind of tell it because it's the amount of different sales calls that we'll get of people selling similar things, and we're getting a massive influx of, we have an AI/machine learning / reporting analytics platform, and that's just a big trend right now.
Well, it's kind of like, everybody, as we went through the different kinds of, video movie stores, or a few years ago, everybody was saying we're all sustainable and green, and it's kind of the flavor of the month. And I guess this is kind of like you said with IoT, everybody's doing it. It's the same thing, over again. And so anybody can write an algorithm, do some code, and put it on a screen. Then just to interject an additional question, what characterizes a good data analytics program then would be doing the cleaning and the aggregating and what else?
Well, I think it's more that what makes the most use out of a good machine learning or data analyzation program is having everything set up to begin with. So having a central area where data is stored. So it's okay to have multiple local sources that are collecting data and buffering data, because if you lose a connection, then at least it's locally. So when that connection is made to the enterprise historian or the main top level place that data is aggregated, then it can all be put there. So to have a central location where data is stored, and to have it stored in a way that makes sense. So think about it from, let's say that you were just looking at a mixed tank, for example, and you're measuring temperature on it. So let's say that you've got two mixed tanks that you want to measure temperature on, and one mixed tank, the data, the way that the temperature is called out tag-wise and what it's named and way that it's pulled in and everything is completely separate from the second one. Well, throwing a reporting tool over the top of that's not going to make much sense when you go to apply the data model for the first tank to the second tank, right? So there's got to be some uniformity there and some ways things are collected, and you're obviously not going to want to collect temperature when you're not running the mixed tank. So it might make sense to have some triggers that say, hey, now's the time when the tank's running, so let's look at it. And if that exists in one tank but not in the other, not much use to you. So think about that on a plant-wide basis where you're collecting tons and tons of process variables across bunches of different of equipment types, and some of those equipment types are made by different vendors, so it's completely different on the inside, and that's why having a good model to begin with, it's more of being able to make the most use out of your reporting analytics platform means that you need to put the work into actually developing a good data model.
So as with, historians, what are some of the new places, the applications, where these tools are being used that maybe they weren't before because it was too costly or time-consuming or difficult?
Well, and that kind of goes back to your previous question on the positive side. Some of the things that we're seeing that tie in with this is, the big one is we're seeing reporting platforms and historians be used to influence control. And that's really something that it's been great to see, and it's been something we've been pushing for a while, which is making use of your data can be as simple as making good decisions or making process changes or deciding to run things at different times and so on and so forth. But the big one is being able to take what's coming out of your reporting platform, using the data that you're getting from your historian, and actually make real-time process decisions without having to intervene from a human standpoint. So let's say that you're collecting environmental data and you realize, hey, based on what we know about our data model, humidity is at a certain point where the end product is not going to be the quality that we would want. So let's change a process variable as it's running through here that's going to be able to make sure that our end product is of the quality or will meet specifications that we're looking for. So that's a big place that we're seeing, and that goes back to the PAT or process analytical technology that I was mentioning. And the other one is that we're seeing a lot more tools and features that are being added to help you analyze the data, connect outside data sources. So it used to be a lot more difficult than it is now to take different databases that exist, or let's say that somebody has a lab notebook or some sort of process notebook that they're entering data into, and it used to be a little bit more difficult than it is now to pull that into one place. And we're seeing a lot of historian platforms, and with OPC being where it is now and there being the amount of drivers that exist, it's a lot easier to connect up your data sources and put them into a single location. And the tools that are available that are coming out for that are big. So that's kind of on the reporting side. And on the historian side, what we're seeing is the advent of the enterprise historian just becoming more of a reality. And so we used to deal more often with these islands of automation and smaller historian systems because it made more sense to separate them out just in case something were to happen. At least you could have the data. And now the way that historians are being set up, it's a lot easier to have all of these local collectors that get fed up into one main enterprise historian. So you have this one area that you are putting data into, and it may be collecting it from multiple sources, and it may be buffering locally so that when you lose connection, it's stored so that it can be put up to the enterprise level later. But the enterprise historian is becoming a lot more useful and a lot more widely implemented than it used to.
So these are process enterprise. Is it process/enterprise historian or process historian, or what do we call it?
We refer to it as an enterprise historian, and what we usually mean by enterprise historian is it is the place where all of the data is stored. So you may have like an enterprise level historian for a company globally, or it may be on a plant basis. But let's look at a plant level. So on a plant level, the enterprise historian would be taking data from multiple local sources. So maybe you have a couple of smaller local historians, and maybe that's per process area or per line or per division, and then that's getting set up into an enterprise historian, and that enterprise historian usually sits higher up in the food chain networking-wise, so to speak. So you might see that rather than be on the plant floor network, that might be on the business network, and might be a level up because that may be the place that the MES system or an ERP system is interacting with, or you may be making business decisions upon that data that's being collected. So it's a little bit higher up in the food chain.
And the historians that I remember covering were kind of cube-shaped boxes with large numbers, and the thing you're talking about is pretty much purely software, is it not?
Yeah, and that's really where historians have moved to is purely software. So we still deal with what you're talking about, and it's kind of evolved. It used to be paper chart recorders. I mean, that's the ultimate, right? Actually, I mean, the ultimate is a person that walks around every hour and looks at process variables and writes them down on a piece of paper, and boom, you've got a data historian. And then a step up from that, you've got your paper chart recorders that you don't see too much of anymore, at least in what we're doing, but some still exist, and that's where you're measuring some process values, and that piece of paper swirls around, and you get to collect your data that way, and then you store them in some desk that either nobody knows where it's at or nobody touches them, and that's actually, we've seen that before where that's being stored, but everyone doesn't know where it's stored. And then the step up from that is a videographic recorder, which is what you're talking about. So it's the boxes that either process data is fed directly into, so they have their own I/O similar to what you would see in a PLC or a DCS. Wires get physically wired to it, and it collects data, stores it locally, and then either pushes it to a server application, or there's something that's reading that data via OPC to bring that into a different historian or like an enterprise level historian. But most historians now are all software based. So it's on a server or a computer somewhere, and on an enterprise level, it's usually going to be in their virtual infrastructure or their own cloud that they have. And that's where all the data is residing, and all the data sources are being kind of filtered into that.
All right. So is there any, experiences that you yourself or Panacea has, been through or best practices to share about applying historians or data analytics that the listeners maybe can use in their, applications?
Of course. Yeah. There's really, let's split it up into two different situations. So let's look at customers that are either building a greenfield facility, or they are upgrading they're upgrading an existing facility. But it's going to be new equipment, so they kind of have control over what's coming in. I think that in that situation, it's extremely important to set standards right off the bat. You need to look at how it is that you're going to collect data. What does your tag structure look like? What is the process flow of our data going to be? What sources are we going to be collecting it from? What drivers are available for OPC for that? So just lay out a plan ahead of time of how it is that you're going to collect data, what you want that data to look like, and then transition into what are you going to do with that data? So who's going to be using that data? Who do you expect to be seeing that data? What reports do they want? What are the kind of things that they're hoping to get out of it? Because this is all really going to start shaping your overall data model and how you're going to collect it and what you're going to do with it, what you want your reports to look like. Because a bad strategy is to say, we're going to collect all the data and we're going to have a report that has everything on it, because that report becomes a lot of noise. It's as you know, Jim, I like to relate a lot of things back to safety systems, and it's no different than if you had a safety system that had bunches of different colors and a bunch of sirens blaring at you. It may be great at the beginning, but after a while, it's just noise. And how do you make decisions on that much noise, especially when it's critical? So laying out those standards ahead of time is going to make sure that the right people get the right data, you're collecting the right data, and you're collecting the right data appropriately, and the data is structured in a way that makes sense. That will save you tons and tons of time. On the other end is if you have an existing infrastructure or you've got an existing plant and you're kind of looking to either implement some sort of data historian, or you're looking to move to an enterprise level, or you're looking to make better use of your data, it's not too late to start. I think that's what scares a lot of people. But the trick is that it's a very difficult beast to tackle on a plant-wide or a global-wide basis. So if you go and say, hey, at our plant, we're now going to move to this new way of doing things, we're going to start collecting data, making better reports, let's go. In our experience, that's not very successful. Now, what is successful is to have a feasibility study to take a look at what is our infrastructure, what would we like to do with our data, how do we want to collect data, and doing just a brief study of here's all your equipment, here's what's capable of producing data, here's what's not, creating a plan of how it is that you're going to get your overall infrastructure up to a point where you can collect the data that you want. And then once you're there, run a pilot study on either a piece of equipment or a small process area or just a process area in general. So go through the whole process of implementing the historian, creating the right reports, getting the stakeholders to the table, and that includes IT. IT is very important in this situation. So bring IT, bring operations, bring engineering, bring automation into it, and have everybody sit down and decide what is it that we want to do with our data, how are we going to collect the data, execute that on the small process area, get some lessons learned from that, and then do it on the next process area. And if you kind of move process area by process area or group by group, so you start with production and maybe you move to facilities afterwards, you're more likely to be a lot successful there because you'll have a working model, you'll have a set way of doing things, and you'll have some lessons learned each time you move through there. And that's how you'll be most successful.
So if people are, facing, and most people, at least in North America, have a brownfield existing facilities, and like you said, they're reticent to do this. When you work with folks like that, how do you, get them over the hump, so to speak, or get them to, think that this can be done?
So we always start very small. So we start with a very small 4 to 6 week study. It usually takes less than that, but there's usually these little ancillary things that will pop up that we have to chase down while we're doing that. And so we come in, we take a look at their network architecture, we take a look at how the plant currently runs, we take a look at the equipment that they have, the data that they are collecting, how it is that they collect that data. And then we talk to the people that use the data and figure out, not with the limitations of your system now or not with how you're doing things now, but what is it that you want? What reports do you want? What do you want those reports to look like? What are you hoping to accomplish with your data? And then we usually get, if you bring it from a perspective of not how is your plant currently running and how would you change it, but in an ideal scenario, you walk in the ribbon cutting ceremonies today and you get a brand new plant that does exactly what you want it to do. What does that look like from a data and reporting standpoint? And then when you get that information, then we create a report that says, here's what your current process is, your current state is, here's your desired end state, and here's what it would take to get there. In addition to that, here's based on all of the clients that we work with, either based on your industry or based on what you're doing, here's what we think that you should think about that maybe you aren't currently thinking about. And then that usually comes with a recommendation for what area to do as a pilot study, because we'll spend enough time with them to know that either a low impact process area or a process area that will have the most buy-in, because that's really important. And then once we deliver that report to them, then we've usually gone through and executed that initial portion on the recommended area that we put forward. And then from there, help them build out a plan to either, with our help, accomplish the next process areas or drive something internally to be able to deploy it site-wide after that. So that's usually been the process that we go through, and that's what we've seen the most success, because it's small steps that you build into a greater picture. It's very difficult to just jump right into a site-wide type deployment, because what you'll end up with is just a brand new historian collecting data in the same way that it is currently, with reports that look exactly like they do now, just on a different software platform, and that's not really valuable to anybody. It's no different than if you migrate a PLC, you should modernize that PLC. You should take use of the new features that it includes, and you should drive optimization where possible. You shouldn't just shove old code in new plastic. And it's the same thing with historians.
Okay, well, I hesitate to ask because I'm really uncertain about what comes next, but how do you think historians and data analytics are likely to continue evolving in the future? I guess just more software and cloud and edge and stuff like that, and fog and those kind of things, I assume. But what do you think?
Yeah, I think that you'll see a lot more cloud-based applications, but not for the reasons maybe that some people think, which is, hey, we're all moving to the cloud, let's go to the cloud. I think it's more that you'll see a lot more data analytics solutions go to the cloud because it'll be easier to get processing power to drive optimization efforts that way. So the more that data reporting and data analytics tools get pushed in the cloud, the more processing power that they have. So you're kind of dealing with when you push into the cloud, like something like Amazon Web Services, then it's a lot easier to use their processing power than to go build, the kind of server infrastructure that you might need to, especially for a small to mid-sized company. And so pushing it into there means that you can have the same level of data optimization and same level of multivariate analysis that a lot of, as if you had your own server cluster right there on site. And I think that there's something that you'll see a big evolution into. But the real big connection there, because a lot of that's already happening, is when you see it come full circle. And we've done that with some of our clients, and it's always great to see the results of that. But when you're able to take complex analyzers or sensor data or just overall process data, you've got to a point where it's all contextualized properly, and then it's put into a place where you're able to report upon it and then actually use data analytics. Now, using those data analytics to feed directly into the control system, and from an automation standpoint, without actually going in there and changing set points, but your process will actually change on its own based on what it's seeing from that data analytics. I think that's really the next thing that you're going to see. And there's been efficiencies around the way that data is compressed and collected, and with how inexpensive storage is now, I don't really think that's an issue. The real next step is the increase in the analytics and being able to make decisions on analytics, but decisions that are done without you having to make them. So you'll see yield rates go up, and you'll see production rates increase just by simply having that. And I think that's really the future.
But this would be something, autonomous, and I people are always worried about, oh no, AI, the Terminator's coming to get me, or it's going to take my job. But, just as, we have automatic controls, or even back to relays and things, if something exceeds a set point or goes, below, and, an alarm or alert is triggered, this is kind of similar to that, and I guess, and then, the data analytics would be able to monitor and make, more sophisticated decisions than just responding to set points. Is that a way to think about this for people, or?
Absolutely, you nailed that. I think that it's in the same vein of, if I were to ask you the question, where is the cloud? The proper answer is it's on somebody else's computer. I know it's a running IT joke, but it's the absolute truth. The cloud is really just the same thing that you would have if you built your own server farm. It's just that somebody else owns it, and they own a heck of a lot more than you'd be able to, so they're able to kind of divvy up processor. Basically, think of it like processing as a utility, and they're able to divvy it up where it's needed. So no different than AI or machine learning in the respect to industrial automation. So I think that a lot of people hear AI and they hear what I just talked about with feeding in real-time autonomous control, and they think of this sentient computer program that's making decisions for them, and could potentially get corrupted and take over the plant and become self-aware. And I think that's what a lot of people equate those. But really, it's just somebody that's created a really good algorithm that is proven in the field that's being applied to your specific situation. So it's really just an algorithm that's chugging away. It's a very complex algorithm, and it takes a lot of processing speed, and it's not something that you would be able to do potentially in your own infrastructure, but that's really what it is. So it's the same kind of concept, and it's not nearly as scary as it sounds, and it's very useful.
Well, they always seem the evil robot, evil things always seem to have red eyes in the recent popular fiction and stuff like that. But a lot of the algorithms are created by people, and they're meant to be assistive. I know some things can be annoying, or all these bells and whistles you might not need. But if you can pick and choose ahead of time, they could be very helpful to folks, and folks using that, whether they're using the electricity or the chilled water, and then thinking of information or even power as the same kinds of things. These tools would free them up to do stuff they would prefer to be doing, as opposed to walking around with that piece of paper and the clipboard, right?
Absolutely. I think that that's really the next evolution in data reporting and analytics is we like to, because we do a lot of things that bring automated processes to like scientists, for example. And what we like to say is that, scientists, and it's no different than people that run plants, your job running a plant shouldn't be just to run that plant. I know that's what it seems like, and that's what a lot of people do is you get hired on as an automation engineer or as a plant engineer, and what you're doing is running the plant. But really what you're supposed to be is optimizing the plant. You're supposed to be looking for ways to do things differently. Can we put the equipment together in a way that might save us a little bit of time, or is there process efficiencies that we can drive, or if we did this to the process, would it potentially make it better? Well, having these kind of platforms eliminate a lot of the things that people are doing of like, oh, why did that product come out like that? Let's go tweak the temperature up a little bit because that might be it. Let's go look at the batch records from a year ago when it was being produced right and see if we can figure out what's going on. And this helps save all of that time. So you can put that time where it matters, which is driving efficiencies and making things better and trying to put you and your team in a position where you have the time to go drive optimization. And that's really where it's at.
Well, Will, those were, as usual, some terrific insights. I, for one, feel less jaundiced against historians for, becoming so generic, or as I thought. I'm less confused about data analytics, and in my case, I feel like I'm more able to tackle my upcoming stories. Thanks again for talking to us today.
Of course. Thank you for having me.
Well, this has been another Control Amplified podcast. I'm Jim Montague. Thanks for listening. And please remember that Control Amplified podcasts are available at the iTunes Store and at Google Play Podcasts. Plus, you can always go and listen to them at good old controlglobal.com. Thanks very much.